In this video, our main purpose is to look at what's called a recursive formula. A recursive formula is assigned where we use the first term or terms must be given, specifically the nth term by the formula or equation that involves one or more of the terms before it. So recursive means to reuse previous terms, but also, I think bestly described, it's very restrictive. If you don't know the previous terms, you can't get the next terms in the pattern. So if I wanted to find the 100th term, I would need to know the 99th, maybe even the 98th term in order to do that. So it's very restrictive, but it reuses previous terms. So think recursive, restrictive. So for our first examples, we have an A and a B. But how does that notation look? So can we identify the next numbers in the pattern? I don't see that going too badly, but then can we also write the recursive formula? Again, some students will take this very easily, while others will really struggle. So the notation is going to be A sub n minus 1, where a sub 1 has to be given the first term. So there has to be given terms in order to produce the recursive. So in this first one, it goes 1, 3, 9, 27. So if we wanted to know the next term, it looks like we're taking 27, and we're going to be timesing it by 3, which will be 81, and then so on. So we're taking the previous term. If I wanted to know the next term and I was a math whiz, I would take 81 times 3. And I could get the next pattern in the next one, but I have to know the previous one. So if I want to know the 10th term, I would need to know the 9th term and then times it by 3. So it's very restricted in that sense. So the formula for this, though, would be 3a sub n minus 1. Again, get used to seeing that notation as being the previous term, and then give your first term right there. Okay. This next one, I would have given extra credit in class, or at least candy in class, excuse me, if you could recognize this famous pattern of 1, 1, 2, 3, 5, 8, 13. It's a very famous pattern with it, but it's a lot trickier to figure out what the recursive is. But if we take a look at the first two terms, we can add those two. 1 plus 1 will give you 2. And then if we take these two, 1 plus 2 will give us 3. 2 plus 3 will give us 5. 5 plus 8 will give us 13. So if we take 13 and 8 and we add them, we should get 21, which is the next term. And then 13 plus 21 would be 34, and so on. So we have to add the two previous terms to that. So that is called a sub n minus 2. So it means two previous terms right here. And then a sub n minus 1, one previous term. And then we gave the first two terms of equaling 1. And then we can start that pattern. And that famous pattern is called the Fibonacci sequence. And it's found in nature all over the place. And hopefully we'll be able to explore that a little bit more in future lessons. Okay, here's a couple of examples. How do you work with it? This example is just write down the first 5 terms. So many people will do just fine with this one. How do we define, it's defined with that. So the first term is given as 2, and then it's a sub n equals 4, a sub n minus 1. Again, this means previous term right here, a sub n minus 1. We're taking the previous term and we're adding 4 to it. So in words, the 5th term equals the 4th term plus 4. So if we want to find these terms, a lot of students can maybe just, the first term is 2, and then you're going to take the previous term 2 and add 4 to it, so the next term would be 6. Some people, because the formulas are going to get harder than this, really need to show themselves the algebra behind it. So one option is to do this, so you find the first terms, is to list algebra. So they give you the first term, I write that down. Second term, in order to do this, I put a 2 right here, and wherever there is an n in the formula, right here, I would put a 2 and a 2 into the formula, and I would get 2 right over here, minus 1 gives you n sub 1. So you can actually get the n sub 1. And then I've seen students plug that 2 in and those 3 in. So plug in the n value right here and you will get those next terms. And once you establish the pattern, then you can probably toss away the formula and then just simply say, okay, 2 plus 6, then a 10, and then 14, 18, and then you're going to keep going up. So those are the first 5 terms, but they mean previous term plus 4. Oh, and then the terms are 2, 6, 10, 14, and 18. All right, here is example 6 and 7. 6 has an asterisk if you are using the guided notes. Again, that means there's an author in action video for him to step you through this as well as I will too. So you can kind of work through that. Notice I'm just switching up some notation to U's and S's to help out, that it doesn't always have to be A in that formula. So this one, for number 6, we're trying to write the sequence down in a recursive formula, write down the first 5 terms. So same directions. So our first term is just 5, and then 2 times Sn minus 1 means the previous term. So if our first number is 5, then what we have to do is take that term, and then we have to write it down, and then take the previous number and multiply it by 2. So this one will go 5, 10, 20, 40, 80. Again, you're going to take the previous term and times it by 2. So our next term that we don't have written down, if we wanted more, would be take 80 and times it by 2. So that would be 160. So unless I know the previous term, I can't double it to get to the next one. So it's very restricted and limited with recursive. All right, example number 7. First term is 1, second term is 1, and they want you to write u sub n plus 2 equals u sub n plus u sub n plus 1. So this is just a different notation of saying one number plus the number in front of it of n and n plus 1. So again, I encourage you to take the number 1 and the number 2. If I want to find the third term right here, I would just plug in the number 1, and then that will give me u sub 3. So I have to plug in 1 here and 1 right here into both ends, and you're going to get u sub n minus 1 and u sub n minus 2, which were given. So actually this one is, again, another way to write the Fibonacci sequence of 1, 1, 2, 3.